For decades, robots ruled a very specific, highly structured world. They thrived inside tightly controlled labs, operating behind heavy steel cages or bolted down to perfectly predictable factory floors. But right now, that's changing. These machines are actively crossing the boundary out of the lab and into our messy, unpredictable, everyday reality. In this explainer, we're going to break down the invisible system that's finally making this massive transition possible. To really grasp the scale of this shift, think about this wild engineering contradiction for a second. In a factory, an industrial robot can build a car with absolute perfect precision. It executes its programming flawlessly every single time. But if you take that exact same multi-million-dollar robotic arm and place it in a standard living room just to pick up a drop towel, it completely falls apart. The real world is just incredibly messy. The lighting shifts, objects move around, humans get in the way. It's a completely different game.
Now, we didn't just arrive at this point overnight. Back in the 1980s, robotics was pretty much entirely defined by those caged factory arms, heavy, isolated, and kept far away from human workers for safety. By the 2010s, things evolved, and we started seeing roaming, autonomous mobile robots navigating the busy floors of logistics warehouses. And today, in the 2020s, we've hit the bleeding edge. Physical AI operating directly in human spaces. Untethered, agile, and working right alongside us.
And look, this isn't just some fun science experiment anymore. We're talking about a massive economic shift. According to the latest data from the International Federation of Robotics, deployments of professional service robots are absolutely surging across logistics, healthcare, and agriculture. Driven by severe labor shortages across the board, these machines are rapidly expanding out of traditional manufacturing and into highly dynamic professional environments.
So what's the actual catalyst here? Well, it's a system known as physical AI. And this is totally different from the AI you use to draft emails or generate images. Physical AI models are specifically designed to perceive, understand, and interact directly with the physical world. It's the underlying intelligence that lets a machine look at a chaotic, completely unstructured environment, calculate the complex geometry in real time, and actually manipulate it. You see, a robot really isn't just a piece of hardware anymore. It's powered by what we call a hidden robot stack. We're talking incredibly advanced sensors, localized edge computing so it can think on the fly, hyper-realistic simulation training, and high-density battery tech. The whole reason robots are breaking out of the lab right now is because this entire infrastructure is finally maturing all at once. It's this incredible convergence of technologies peaking at the exact same time.
Just to walk across a single, normal room, a robot has to execute a rapid, continuous feedback loop. First, it has to see, meaning it needs to instantly perceive its environment. Second, it must decide and safely plan its exact movements. And third, it has to act, executing the physical motion while simultaneously correcting its balance. A machine is literally running this cycle hundreds of times per second, and if any part of that loop lags, even for a millisecond, the whole system fails.
To put this into perspective, think about the difference between a purely digital system and a physical one. If an AI chatbot messes up with its data, it just spits out a wrong line of code, right? It's harmless. But a physical robot, it isn't just processing text, it's fighting gravity, friction, momentum, and completely unpredictable human beings. A physical machine has to be incredibly robust just to survive a basic walk down the hallway. And to survive out there, they need some serious hardware. Advanced perception is absolutely crucial. We're talking depth cameras that map 3D space in real time, LiDAR systems shooting lasers to measure precise distances. They have force sensors in their joints to calculate weight, and even tactile feedback that mimics human touch in robotic fingertips. Because these sensors are finally both cheap and powerful, these machines don't have to rely on pre-programmed tracks painted on a factory floor anymore. But all of this brings us to a really fundamental question. Why is a basic, everyday human task, like folding a piece of laundry or figuring out a tricky door handle, still so incredibly hard for a multi-million-dollar machine? Because despite the viral videos and the online hype, general-purpose tasks remain a massive engineering bottleneck. Let's break down the real-world bottlenecks keeping things in check. First, dexterous manipulation. Actually building and programming human-like hands is remarkably complex. Then you have severe energy constraints. A humanoid robot drains massive battery power literally just trying to stand upright. Toss in the sheer economic cost of maintenance, plus the unpredictable chaos of sharing a workspace with humans, and it turns out fully general-purpose robots are still really difficult to deploy profitably. But if there is one bottleneck that tops them all,
It's this number right here, 0. That is the acceptable margin for physical error. A software bug that crashes your favorite app is an inconvenience, but a software bug in a heavy, autonomous machine navigating a crowded factory, that causes catastrophic physical damage. Physical AI just requires a completely different, almost impossibly high standard of safety and reliability. So how do engineers actually solve that safety bottleneck? The answer is synthetic training. You see, training a robot entirely in the real world is slow, it's dangerous, and it is incredibly expensive. Every time it falls over, hardware breaks. Instead, engineers build highly accurate digital twins of our reality. Inside these simulations, the AI runs a specific task millions of times, failing, learning, and adapting safely at warp speed, long before that digital brain is ever downloaded into a physical body.
Because of these immense challenges, the roadmap for what happens next is actually pretty clear. We're not going to see general-purpose robots everywhere all at once. The expansion is going to happen in controlled spaces first. Robots are only going to deploy where the environment is semi-structured, highly measurable, and where there is a massive financial incentive to automate.
In fact, this transition is already happening in specific industries today. In massive warehouses, autonomous mobile robots are already handling heavy, repetitive logistics. In hospitals, specialized service bots are delivering lab samples up and down perfectly predictable corridors. Out on farms, advanced drones and rovers are actively inspecting crops. These are environments that provide incredible economic value, and importantly, they are structured enough for today's AI to actually thrive.
There is a brilliant quote from the source material that sums this up perfectly. Robots are not leaving the lab because they suddenly became perfect. They are leaving because the world around them is finally becoming machine-readable. It isn't just the robotic hardware evolving. Our modern infrastructure, the AI, the sensors, the edge computing, is actively translating our chaotic physical reality into structured data that machines can actually process and understand.
And that right there is the ultimate shift we're witnessing. As we digitize our global logistics networks, map out our hospitals, and deploy smart infrastructure, we are actively preparing our physical spaces to accommodate physical AI. The massive gap between the clean, structured lab and the messy real world is closing, mostly because we're finally teaching the machines how to read the mess.
As this hidden system of sensors and AI continues to mature, it leaves us with a pretty profound question to end this explainer. What happens to our daily lives when every space around us, our offices, our streets, and eventually even our homes, is built not just for humans, but specifically designed to be navigated by autonomous machines? Ready or not, that transition has already begun.